plane and then tunneled through other things in hardwood, so that you have this kind of lattice work, like here. And it's only after they've done all that they realized that X-rays were such a useful tool to look at paintings. Now they had affixed permanently this hardwood to the back, which when you take your X-ray, shows up much more than the detail of the painting that you want to see. That's the cradle. I said, well, I've never seen this before. And I said, no, because when we publish these pictures, we first spend hours and hours and hours removing them. Just removing them. Yes, they say, because we do that in Photoshop. So every art conservation studio has one person who's become very good in Photoshop because they remove this manually. And I said, well, maybe we can do something about that. And so that's what it became actually a very, very interesting project, because let's go look here again. So what you have zones where the intensity is different. You say, okay, that's easy. I just find those, and well, they're not exactly horizontal or vertical, so you have to work a little bit at finding them. But I mean, what she did is, this is one of my students. She actually did a kind of a radon transform in the plane of the wavelength transform first, in order to find exactly the line up of the edges, and so that you could characterize the zones, and then you can adjust intensity. Okay. But then, I mean, as soon as they saw that we could do things, but to them are like magic, they became greedy. I mean, they also really like to have the wood grain removed. You see here the wood grain of the horizontal member, because the wood grain of this painting is vertical, but all the horizontal wood grain is of the sliding member. So they wanted to not just have intensity adjusted, but the wood grain. But they wanted to keep the wood grain of the gold panel, because that is of interest to them. So you now have zones. You know that in some zones you have information on only wood grain of one panel. In other zones you have information on wood grain of the original panel, and of something else. And that information is correlated with wood grain here, because it's the same piece of wood. It's not the same, because wood grain varies. So this became a very interesting machine learning problem, in which you had to find the right ways to represent all these different textures, and we used fast decompositions for that, and dictionary learning, in order to find the right way to represent those wood grains, so that we could subtract one and not the other. And so in the virtual cradle removal, so here you see what on the right you see what the art conservator who's expert in this would have done with it in Photoshop, and on the left you see what our algorithm, what Rachel Yin's algorithm does. So they were very excited, and we then obtained a grant from an art foundation. So this is the first time that I got a grant from an art foundation. Actually, the letter that gave me the grant said I kept it. It said this was an unusual proposal for them, although they do things for scientific things, for study of art. It's usually with more traditional things, X-ray campaigns and so on. And the person writing the letter said it had led to one of the most interesting and lively meetings of their board that in recent history. So I guess there must have been people who said, "Oh, this is great," and others said, "Oh, crazy." And but anyway, they gave us the grant, and we had to refine the mathematics of it and make it more robust. Then it was ported from MATLAB code into C++ code, and then we hired people who are experts in writing plugins for Photoshop, because MATLAB or C++, I mean, even if it can do miracles, if you give that to somebody in art conservation studio won't do anything. I mean, they don't have MATLAB, they don't want to learn it. But Photoshop they have, and so we had a wrapper written for it in Photoshop, so that we have now a